Great. All right. I think this is the best setup I have ever had for giving a talk, and I'm happy maybe we can take questions on that butterfly research later. But in addition to that, we also do project-based cures where we use open science data in my classrooms to do analysis of physiological responses to the environment. And what I'm going to be talking about today is a tool we developed for more assignment-based cures. So widely disseminated using open access data, but really the kinds of worksheets and modules that can be applied in a variety of different settings. And our goal is to use interactive data visualizations for students to explore biological responses to climate change. And what really drives my research, and something I think we really need to understand better in order to take the necessary action in climate change, is to think about unpredictability. So on average, we see organisms are tracking environments by moving uphill. They are moving towards higher latitudes, but we also see a lot of variation. So this is data about how a suite of different taxa have responded to about 100 years and a few degrees Celsius of climate change, and you will see a lot of variability here. And this is the type of concept that we really want students to engage with data to better understand where this data comes from, so that we might in the future be able to better predict climate change responses. And we think key to addressing this unpredictability is to think about both how organisms are experiencing their environment and how sensitive they are to the environment. So most climate change projections you see in the media, wherever, are based on assuming that organisms' body temperatures are equal to air temperature, usually high above the ground. But just some quick thermal images, we love thermal images, to show you that there's a lot of variability out there. And this is, again, a type of concept that we really want students to grapple with. So my lab runs what we call the Trench Project, so tools for translating environmental change into organismal responses. And this is an open science resource trying to make thermal ecology open and reproducible, trying to give more people the tools so they can really understand how organisms are experiencing climate change and how they might respond. And all this stuff I'm going to talk about today is up on our GitHub site, so I would welcome anyone to check it out, pull down our data, use it, adapt it, whatever works. And just briefly on the science side of this, again, what we're trying to do is we're trying to make microclimate models more accessible so that people can understand how organisms experience environmental change. And then we do what's called biophysical modeling, so we translate these environmental drivers into things like the body temperatures of organisms. And I'm going a bit into the detail here because this is a field that these models have been around for substantially for about 4 decades, and much further back if you look more broadly. But all of these models have not really been used because they were basically patented with proprietary software. So we've actually had to recreate a lot of these models and a lot of tools to try to get these tools out there so that people can use them more frequently, because we think you really need these tools to get the right answer when you're thinking about climate change. So that's a little bit on the science side because it directly maps onto the education component of our research. So we have what's called Trench Ed here. And we've already heard some mention of R-Shiny, so a really simple to use, accessible tool to do interactive data visualizations. So we have a lot of undergrads, other people in my lab that have contributed to developing these R-Shiny applications. And again, everything is up on GitHub, so they are easy to manipulate and access. Also introduced all these educational alignments. So one of our core goals, actually through working with Ellie and also local high school teachers, was to align our modules with vision and change that we've heard discussed, and also with the BioCore that is outlining the vision and change concepts, and also BioSkills, which is basically translating the vision and change into something that is our skills that we could readily include in our modules. And so when we built these visualizations, I sort of started them through my undergrad class, so they started as an undergrad tool, but we really wanted to, or anyone here that teaches undergrads, you realize a lot of them come to you not necessarily knowing how to read graphs, not necessarily knowing how to interpret the data, so we really wanted to start earlier. And it was great that we were able to work with local high school students to also align our modules with next generation science standards. And because it's a program somewhat under threat right now, I want to highlight that we were able to do this through the NSF Career Program, which was great. We worked with the UW program on climate change. We also worked with local high school teachers. And I want to highlight Mira here, who is a scientist that has a science writing background. And that science writing background was just phenomenal for trying to engage students with the data. And one of the key components of this Trench Ed project was that we profiled a lot of different scientists that had collected the data that went into these visualizations to, again, do this humanization of science process. And we were able to include quite a few undergrads like Brian Briones-Ortiz, who's now a grad student, but he started working with us and helped us develop these visualizations as an undergraduate student. And again, we really highlight the diverse pathways that people took to get into science. So one person, Cesar Nufio, who's our collaborator, who generated an amazing amount of really interesting research. He has a great story of actually being a community college student and coming upon this historic collection by chance and deciding to do this resurvey project. So we think we have a lot of fun stories in there to try to make science seem more accessible. And we have also stories, the concepts of the science. So when you get to our Trench Ed website, we encourage people to think about these different concepts. So climate change, physiology, gradients, how you might use historic data. We start out with an interactive visualization to get people used to looking at data with graphs. Our Shiny makes it really easy to have tours of interactive visualization, so we have that for all of our different modules. And I think we have about 10 different interactive modules overall, so they are covering a variety of biological topics and a variety of different organisms. So because it's well aligned with science standards, we tend to hit temperature, energy balances quite a bit, and then get into some of the responses to climate change, like phenological and range shifts that you see a lot in the media. We want students to be able to better understand the data behind those changes. So just briefly, this is the landing page for one of our visualizations. This is looking at phenological shifts at high altitude. If anyone has heard the story of Billy Barr, who has lived basically in a cabin in the woods at this research station, he got a lot of media attention during the pandemic because he knew how to socially isolate. But he collected an amazing data set over about 3 or 4 decades. So again, trying to humanize this, tell his story of how this data came about. And then students come upon this interactive visualization. There are worksheets I'll talk about in a moment that lead students through to developing hypotheses. And once they have their hypotheses, they think about how they actually evaluate that hypotheses with the data so they can pick what they want to plot out, and then the worksheets will guide them through interpreting these plots. And again, probably a lot of you already might know how to make our Shiny apps, but it's incredibly easy to make these visualizations in education settings. And we also have a resource page, which we have teacher guides at both the high school and the college level. And this is the undergrad teaching guide. So it will go in general through what these core concepts and competencies that we're working towards are, and then we shift into thinking about the specifics. So for example, we have physiology, ecology, and evolutionary biology, core concepts, transformation of energy and matter. So we show those core concepts, and then we talk about how our modules are trying to address these concepts, and we give examples of which modules address each concept here. Do the same thing for core competencies. And this is looking at a worksheet that is aligned with that module I just showed, where we're also trying to make sure that the students using these materials know what concepts they are learning and what competencies they are developing. So we have those resources there. And we also have a lot of other resources for learning the background of these different science. And then also just to highlight on the right that there's equivalent versions of all these worksheets for high school students. So I want to briefly transition to the education research side of this, since this is a large topic of discussion here. So I think probably many of you think that interactive data visualizations would be really helpful for things like graph thinking, evaluating and interpreting evidence, and understanding variability. And we have done some basic assessment of our tools, but we would love to do a lot more. If anyone would be interested in collaborating on this type of thing, I would love it, because all of these materials are available online, really accessible, so I'd be excited about collaboration. But in preparation for talking about this, I did look in the literature a little bit. Maybe some of you can help me with other resources, but there really hasn't been all that much evaluation yet. Most of the studies have pretty small sample sizes. So this is a statistics interactive visualization with R-Shiny, showing that students generally like it. There's some reduction of statistical anxiety, but not, still I think a lot of work to do to figure out how we can use these interactive visualizations. Another area of research that has this, just recently published, this is an ecological forecasting initiative, and here for both undergrad and graduate students, they are showing some improvement in correct answers that are hitting these various areas. And on the right, they are showing that people using these interactive visualizations have refined their understanding of the process of science. They're better making connections at these different steps. But again, relatively small sample sizes here. And I think it was interesting to me through this to really get a sense of there's a lot more work to do to understand how interactive visualizations can be used to extend student understanding. And as Gwen was talking about earlier, in principle, these types of access with data, it's really can be disseminated anywhere and can be a really easy way to get students doing inquiry-based research. So I would love to have the time to think more and work with people more to think about the educational value of interactive visualizations. So briefly, I want to mention that we think another great tool for having people engage with climate change is to look at these thermal images. You can now get cheap adapters to phones so people can easily take these thermal images. And so we have a repository where we're asking people to upload these thermal images. And we also have a series of educational modules that ask students to interpret these images. Great, so I think I did manage to leave plenty of time to answer questions about my talk and maybe Gwen's talk too. So just to thank all the people that have been involved with making this possible, and I look forward to discussing these topics with everyone.
We do indeed have plenty of time for questions. So our mic runners are coming. Well, maybe to start us off, maybe you can tell us about the collaboration between your two institutions and maybe from both of your perspectives.
Yeah,
think about sort of the process of that collaboration.
Yeah, great. And Gwen probably hit on this a little bit, but not entirely, that when you are trying to me, again, you have this issue of unpredictability in climate change biology. One of the ways we're really going to understand that is by going back to the past and repeating some of these functional studies. And you worry a lot about getting the details right when you do something like that. So this was this amazing win-win opportunity where Gwen was the person that actually collected the data, so we could figure out that we were repeating it in an appropriate manner while also having this really I will say quite smooth and like great way to also involve students in this work. I will say these Edmund students have been absolutely spectacular to work with in our lab. A lot of our UW students that come from different backgrounds, different educational histories than some of these students. Like some of them really have to get their act together, like, because these Edmund students are in there, they're working hard, and it's all around a great dynamic. I could talk about that all day, but I think I will stay it there. Yeah, it's been really great from my perspective to have this mechanism of bridging from a 2-year to a 4-year college. University of Washington has tons of transfer students, and we are always looking for ways to build those bridges. So this was great.
I see we have a question in the back.
Hi, thanks again for the talk. I'm a big data visualization lover, so it's great to see. I was curious in your consideration of the use of, I guess so the biggest thing I think about when I do these things is sort of where issues arise in the pipeline, like who collected which data. Do you think there's a value also to educating students on the shortcomings of the data that was collected, how it was collected, who collected it, and what we can do to sort of ensure quality when working with open data?
Yeah, that is a great point. I will say, so we have mostly done that in this collection by telling the stories about different scientist pathways and some of the fortuitous ways that this data came about. We do not, in this, just for brevity, I guess, not have students engage so much with the process and making mistakes and data quality issues, but that is something we do much more in the context of courses where we have multiple week-long projects. So I think the extent to which we can hit on that at all different formats is great, but I will say it. I guess my concept for these really short modules was more on having students engage the concepts and a little bit of process of science. But that's a great point.
Thank you.
Sure.
All right, right here.
Great talk. I'm interested. I know this is an undergraduate science, undergraduate focused symposium, but I noticed that you alluded a little bit to the high school involvement, and I was wondering in what ways that differed when the application differed, and how you were able to engage high schoolers.
Yeah, that's great. So the application is basically, the actual visualization is the same, but we do have more background and more walking students through the concepts. We have taught quite a few teacher workshops with high school students, and I think a lot of these topics are already taught in undergrad courses. There's this huge proliferation of climate change courses, so our modules are hopefully, and people are picking them up for undergrad courses. I think for the high school level, it takes, maybe it's more the context that we've emphasized of fitting this in with high school classes than it is shifts to the modules as well. So teacher workshops have been really great.
Yeah, the symposium is, as you say, undergraduate focused, but good teaching is good teaching. Any additional questions? All right. Well, thank you.
Yeah.